Hi, this is Anirudh, and in today's video we'll be discussing capacitors as the next section in electrostatics. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. For the first question today we have this. A capacitor is fully charged by a 20-volt battery. It is then discharged through a resistance wire of specific heat 300 Joule per kg per Kelvin and of mass 0.2 kg. If the temperature of the wire rises by 0.1 Kelvin, then the value of the capacitance is. So here what essentially happens is you have the capacitor, and the capacitor is holding a certain amount of energy because of its voltage. As the capacitor discharges, the entire energy is passed through the resistance wire and is converted to heat energy. So we just need to equate the energy. So we'll start with the capacitor energy. The formula for capacitor energy is half CV square. We will use this formula and not half Q square by C because we have the voltage in this case, which is constant. Half into C, we do not know C yet, into V square is 20 square. That will give me 400 by 2, that's just 200 C. We also need to find the energy from the resistance, which we will get by our formula of heat energy, which we did in calorimetry, that is mc theta, mass into specific heat capacity into change in temperature. Mass is 0.2 kg, specific heat capacity is 300, change in temperature is 0.1 Kelvin. So now since this energy is converted to this, we just equate the two energies. So that gives us 200 C is from here is equal to, just right here, EC is equal to ER. EC is 200 C, that is equal to 0.2. So we can write this as 0.02 into 300. Cancel out the hundreds. You have this cancels out 0.01. Therefore, the capacitance is 0.01 into 3, that is 0.03 farad. So our correct option is option 2. The next question says that a thin metal plate P is inserted between the plates of a parallel plate capacitor of capacitance C in such a way that its edges touch the two plates. The capacitance becomes, and we have to find the options. Now the mistake that most students will do here is understanding the geometry of the problem. Most students, like the general sum for this is you have a capacitor and this thin plate is placed in between like this. If the sum is like this, you treat this as two capacitors connected in series. But in the question, this is not the geometry. This geometry is wrong. The correct geometry to this problem is that you have the regular capacitor and the third plate is placed like this. It is facing us. A better way to draw that is if I look at it from the top down, then it would look something like this. If I'm looking at it from top, then these are the original two plates and the third plate is placed like this over here. Now what does this mean? This means that this is no longer a capacitor. This makes it a complete circuit. There is no accumulation of charge. The charge can flow freely through this path throughout the circuit. So the capacitor essentially reduces to an ideal conductor. And the capacitance of an ideal conductor is 0. So in our case, the solution to this problem is that the capacitance becomes 0. The third sum says that two capacitors, each having capacitance C and breakdown voltage V, are joined in series. The capacitance and breakdown voltage of the combination will be. So let's draw out our arrangement. It says you have one capacitor, you have another capacitor, both having capacitance C connected in series. I'm not drawing any battery as of now. Now just like the previous sum, this sum is actually very easy to do and it will be solved very quickly if you know the correct method. Firstly, you need to find the capacitance of the combination. That is simple to do. We know that the two capacitances are connected in series. So the equivalent capacitance is just C1 C2 divided by C1 plus C2. since both are equal capacitance C, so you have C squared divided by 2C. That gives you a C by 2. So equivalent capacitance is C by 2, so our option reduces between this and this. Now they have said that the breakdown voltage V of each capacitor is V. That means each capacitor breaks down when the potential difference across it becomes V. This capacitor breaks down when the potential difference across this is V. So for a cell or a battery to cause it to break down, it needs to give a total potential difference of 2V as the sum of both of them. Hence, if you treat this as a combination, the capacitance becomes C by 2 and the net breakdown voltage multiplies by 2 and it becomes 2V. Hence, our correct option is number 4. The previous sum and this sum, both, like I said, are very direct sums, and you can solve them very quickly if you understand the logic and you know the method. These are important for your JEE because it will save you a lot of time, which other students might waste a lot of time doing. That's all we have for today. I'll see you in the next video with dielectrics. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.